So thanks everybody for joining us today. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and this event is one of them. So we have actually two, one on Tuesday and one on Friday. So on Friday, we have less formal events like this one, where we have, we call them live podcasts, where we talk about different topics. We don't have any slides, and you are on one of them today. We will be talking about data observability, but we will also have events that are more technical that we have on Tuesdays. They are usually with slides. So next week, we will talk about the evaluation store, which is a new category of tools. Check it out. And you can go to our events page, which is at datatalks.club/events, and you can check all the upcoming events. Then, if you want to stay up to date with all our events, so of course the best thing is to join our Slack, and you will have all the announcements in our announcements channel. Then you can join our newsletter and subscribe to this channel. And last, during our chat today, you can ask any question you want. There is a pinned link in the live chat. So just click on this link and ask any question you want. And then during our conversation, I will pick some of the questions and we'll ask our guest. And that's all. And yeah, I think we can go to the main part. Are you ready?
Yeah, of course.
Okay, so let me open my notes. Okay, I have my notes. So this week we will talk about data observability, and we have a special guest today, Barr. Barr is a CEO and co-founder of Monte Carlo, which is a data reliability company. She has experience with building data and analytics team, working as a management consultant, doing research as a research assistant, and even working in Israeli Air Force. So welcome.
Hi, thanks for having me. It's great to be here.
Yes, thanks for coming. So before we go into our main topic of data observability, maybe we can talk a bit about your background. Can you tell us about your career journey so far?
Yeah, absolutely. So as you mentioned, I was actually born and raised in Israel, and so started my career in the Israeli Air Force. I was commander of a data analyst unit. Actually moved to the Bay Area about a decade ago. So I'm located in San Francisco in California. I studied math and statistics. So that's sort of my background in data as well. You know, working as a management consultant, worked a lot with data science teams, working with Fortune 500 companies on their strategy and operations. And then most recently, I joined a company called Gainsight, which is a customer data platform, which created the customer success category. And at Gainsight, actually built and led the team that was responsible for our customer data. So sort of Gainsight on Gainsight. So we called it Gong for short. That was sort of our nickname for it. And we helped our customers basically use data to grow their businesses with their customers. And throughout that experience, actually, you know, sort of leading the team that are responsible for customer data and analytics, realized how big of an issue is some of the very fundamentals around data. As companies try to become data driven and rely on data, they actually ran into instances of what I call data downtime. We'll talk a little bit about that later. But that's when I first sort of encountered it. And so that got me thinking, you know, how is it that we are so advanced in data and yet there's some things that we really just haven't figured out. And so started Monte Carlo with the goal of helping organizations use data, adopt data, become data driven by actually minimizing what I think is the biggest problem, the biggest hurdle, which is data downtime. And so, yeah, it's a big pleasure for us to work with some amazing companies on helping them solve this problem and helping achieve data reliability.
Okay, so you worked, you were leading analytics teams, right? And you were working closely with data, and you noticed, okay, like we have some ideas how to process this data, but when something breaks, then things go wrong, right? And that led you to realizing, okay, there is some gap in the market that you could fill, and then this is why you created the company, right? Is this
Yeah,
accurate?
let me describe to you sort of a scenario that I'm sure is familiar to anyone in sort of data and potentially in engineering as well, right? So, it's always like on a Friday evening at 6 p.m., like 5 minutes before you're just about to log out. Something hits you. Like a customer reaches out and says, "Hey, the data here looks really wrong. Like, what's going on?" You're literally just leaving the office, just about to sign off. And then suddenly something blows up, right? Or this is like 5 minutes before a really important board meeting. The CEO pings you and says, "Hey, the graph here, something with the numbers that I'm showing just looks off. Like, what's going on?" And then it starts this scramble of what went wrong and where. Is the report refreshed? Did all the data arrive? Did someone make a schema change somewhere that sort of messed everything downstream, right? It started this guessing game of what's going wrong, right? And so there's a few problems. One, data teams are often the last to know about these issues. They often find out about these problems from consumers of data, whether that is executives or business units or consumers or actually like users of your product. And the second, it often takes ages to actually understand what the problem is and identify root cause. Our systems are so complex today that there's literally, the ability to pinpoint the root cause is extremely complicated, especially when done in a manual way. And so in seeing this problem come up again and again, both for myself, but also for data teams with other organizations, I was like, are we crazy? Am I crazy? Like, how is it that we, that this problem exists, right? How can it be that we don't have a better way to do this? And that basically inspired, kind of the realization that there is a better way to do it. And the better way to do it is actually based on best practices from engineering.
Now, speaking about best practices, so data observability, and I did a bit of Googling before our talk today. So
Yeah.
data observability is based on the concept of observability, which is a concept from the DevOps world, right?
Yeah.
So maybe before we go into data observability, you can tell us a bit what it means in the DevOps world. What is this best practice you're talking about?
Yeah, absolutely. So I will say in general in data, the data space has been evolving very, very quickly. We're still quite behind in terms of sort of methodologies and frameworks compared to engineering. And so it is actually worthwhile spending time understanding what are these concepts like DevOps and others in software engineering that can help us navigate the space of data and navigate what we want to accomplish in a better way. And so the idea of DevOps basically is, emerged in the last couple of decades. And as a result of companies that move from basically the underlying tech stack become way more complicated, similarly to how they are in data, right? For example, for an organization that's moving from a monolith to a microservice architecture, something that, almost every organization is doing. And as a result of that, there has been the rise of DevOps, which is basically teams that help have a constant pulse on the health of their systems and make sure that all the applications and infrastructure is up and running, right? Now, as part of that, developed the idea of observability. And so observability is this holistic view that includes monitoring, tracking, triaging of incidents to prevent downtime of those systems. And so, really at its core, observability in engineering is broken into three major pillars: metrics, logs, and traces. And basically all of these together help us understand what are the health of the system based on its outputs, and when things are wrong, why, right? So answering basic questions like, is a system healthy? If not, what happened? When did it happen? Are there other events that are correlated that could help us understand what's happening here? And so you have, systems and software to help address the need for observability and monitoring. And really every engineering team today that respects itself has something to manage that, right? A solution like New Relic or Datadog or App Dynamics or PagerDuty, right? All very familiar solutions that help us answer these questions when it comes to applications and infrastructure. And so it's a very important concept in software engineering and one that has been relied on for many years now.
Mm-hmm. Yeah, so these are basically tools. You said the teams were moving from monoliths to microservices, and then usually the microservice is some sort of web service, and tools like Datadog, New Relic, or even open source tools like Prometheus, Grafana,
Yep.
they're tailored to these kind of applications, to web services, right, or something that is always running. While in in the data world, we often have something a bit different. Maybe we more often have batch processes than something that is up and running all the time, and that's why we need a bit of a different approach, right?
Yeah, exactly. It's a different approach, but it's very important to do, right? Let's talk about why it's very important, right? If you think about sort of, I'll draw the analogy of what we call data downtime. Explain what data downtime and what application downtime is. So if we take a specific example, if a company, say an e-commerce company, has a particular website. And like a couple of decades ago, if the website was down, no one noticed because they probably had like a real shop where people actually purchased things, and so the website was something minor that nobody cared about. But today, if your website is down, it's basically your product, right? And so you actually have to manage that very carefully, and you have a commitment to 99.999% uptime, right? Now, today you have all these solutions and many others, like you mentioned, to actually make sure that your website is always up and running. Now, if you think about the corollary of that to data, as you mentioned, maybe a couple of years ago, maybe like 10 years or 5 years ago, who was using your data? It was only a small handful of people. And they were using data very infrequently, right? So maybe only once a quarter to report numbers to the street, right? But today, in today's world, there's way more data engineers, data analysts, data scientists. There's way more people in the organization who are using data to make decisions, to power your product, right? And so if the data is down, that's a big deal. Maybe 10 years ago, it wasn't a big deal because no one is using it, but today it is a big deal.
So, well, I hope the stream is still, yeah, it's still live. Okay, good. So good that,
Sorry about that. Yeah.
yes. To be
Suddenly
honest, I
everything
don't
froze.
remember when, what you were talking about. So, like, yeah, you were saying that data downtime is a big deal because while previously nobody cared about this, today there are all these analysts, data scientists, and everyone else who is using data. We rely on this data, right?
Right.
And if the data is not there, and I know I work as a data analyst, and we build data, we build machine learning things on top of the data. When the data is not there, our models stop working, right? And then we start, okay, what happened? And then we see the data is not there, right? Or the data, like it's usually like it should be maybe, I don't know, 1 million records, but today is only 10,000. Where's the rest,
Yeah.
right? And these failures, they are often silent failures, right? Because the data didn't appear in all volume, like maybe just a fraction of it appeared. And if we don't have monitoring to our machine learning pipeline, it looks okay. Okay, there is some data. Let's apply the model to this data, and yeah, I'm done, right? But yeah, it's silent. We didn't notice that something is wrong. So
Yeah.
yeah, I think you were talking about something like that, right?
Yeah, absolutely. That's exactly right. It's like, the job is completed, it's all green, everything passed, but you know what? You only got, a small fraction of the rows that you were hoping to get or expecting to get. Or you know what? Job completed, you got all the data, but now it's all null value, like all the values are null suddenly, right? Or you got all the data, but it's credit card data, and suddenly you have values that you don't expect, right? Like letters or something that you shouldn't have there, but you never knew because the job was completed and everything was fine. And you might just not know about it. If you're lucky, you might find out about it the same day, but oftentimes it can take weeks or even months until you realize that my model was operating on completely wrong data, for example. Or I was using data to make decisions that was just totally incomplete or actually wrong.
So, so you said like the if we talk about the problems we have with data, about data quality problems, so first you mentioned that, okay, there could be some things that weren't supposed to be there, like letters in the numeric fields, right? Then another problem is data is simply incomplete. We don't have all the rows that were supposed to be there. Like it's instead of 1 million, we have only 100,000, for example, or even less than that. What are the other problems that we can have?
Yeah, great question. So, when we first started, sort of set out to determine what is data observability and what should it mean, one of the common things that we heard was, every data team is different. Every data team is unique, and my data can break for millions of different reasons. And you know what? There might not be even a pattern for all of this. And I actually disagree with that, right? Before we started the company, we actually spoke with hundreds of data teams to identify, basically to come up with sort of a database of all the times and all the reasons for when your data goes wrong, excuse me, for when your data goes wrong and why, right? Like what the root cause is, what is the symptom, and how did you identify it? And what we've seen is actually there are patterns, and there is a coherent set that you could work off, that you could instrument and monitor for, that will help you gain observability, similar to how you do that in observability in for DevOps, right? Even though your applications and your infrastructure can break for a million different reasons, there's still sort of those three core pillars that we talked about that help engineers identify when their systems are down, right? And so for data teams, what are those? What is that framework? What are those metrics? And so we define 5 different pillars for this. And we believe that
three pillars you mentioned. Sorry for interrupting. So it's like metrics, logs, and traces for.
yeah, exactly.
And for data, you said there are 5, right?
Yes, precisely. There are 5, and the 5 that we define, we believe that sort of if you monitor for all of them, instrument and track those, you'll get the same sort of level of confidence in your data. So let's talk about which 5 of those are. We gave a few examples, but the first one is freshness. And so you mentioned, let's say we have a table that gets updated 3 times an hour regularly, and then it hasn't been updated for a full hour, right? That might be a freshness problem, for example, just sort of a simple example. And there's many different ways to think about freshness, but basically it answers the question of, how up to date is my data? The second pillar is volume. And so volume, you shared the example, I expect 1 million rows and I'm getting only 10,000 rows, right? So this basically tells us, the completeness of our data tables. The third pillar is what we call distribution. Distribution basically kind of looks at the range of data. So let's say I expect a certain field to be between 5 and 15, and then suddenly I'm getting values that are in the hundreds or 200s, for example. Or if, for example, I expect credit card fields, and I suddenly get sort of letters instead of numbers. So all of these examples would be under distribution pillar. The fourth pillar is schema, which basically looks at who makes changes to our data and when. So that's both at the table and at the field level. So if a table is added, removed, deprecated, if a field is changed in type. And then the fifth pillar is lineage. And lineage is basically a map, an auto-discovered or auto-reconstructed map of all the dependencies, both upstream and downstream of your data assets. And lineage helps us answer the question of, okay, if I have a freshness problem in a given table, what downstream assets are impacted by that? Maybe no one's using that table, so I don't need to care about that freshness problem. But maybe this actually feeds an important model that someone is using, or maybe this goes into a report that gets sent to a customer regularly, right? What are the dependencies? And then similarly, what are the upstream root causes for these problems? Okay. Right? What may have contributed?
Yeah, you're talking about this, and then I recall that an example we had recently at work. So data changed, the schema changed, and it was announced, of course, like
right.
in the Slack
That's
channel.
Good.
Yes, it's good. But of course, I have so many Slack channels open, and not all of them are read. So I simply missed that, and then 2 weeks later, it stopped working. And then, okay, what happened? like why the data is now in the wrong format, but it was announced, right? So it's and then yeah, if there was something like this, like a map with dependencies, downstream dependencies, then it would have been possible to actually know, okay, this data source is used by this team, and also like I would be one of these users of this data, and then maybe for me I would get a personalized alert that's saying, okay, the data is about to change, you have to take action now, else in 2 weeks your jobs will fail, right? So this
Yeah.
is, I guess, a good illustration of the lineage pillar, right?
Yeah, that's a perfect illustration of a few. It's both the schema pillar, right? Because there was a change in schema. And it sounds like someone manually notified you on Slack, which is very thoughtful. But maybe that should be automated as well, right? And then yes, lineage. You're spot on. That's a great example of how that could have helped. And then you mentioned that it caused the data to just stop arriving, right?
No, it was still arriving, just
It was
not
still
in the
arriving.
format my jobs were expecting.
Got it. Yeah. So in that case, that might be an example of a distribution type problem, right? When it's arriving in a different format. So that's the interesting thing with data downtime, is that oftentimes it includes problems from multiple pillars, and each pillar can have multiple different problems. And so when you're thinking about observability and monitoring, all that good stuff, what you need is a system that can detect all of these and can help you automatically draw insight from this, to your point. And yeah, your example is spot on. I hope that was resolved quickly.
Yeah, it was. Well, I had to stop working on other things and fix that. And yeah, well, at least my code complained that, hey, something is wrong. This field is not there.
That's how
And
you found out about it?
yeah, and it broke, like it didn't work, but it could have been worse, right? If
Yep.
the script, the job kept running. And then I don't know when I would have noticed that. Maybe one
Yeah.
month after that. Yeah, you also mentioned that there are other things like in usual observability, in DevOps, in the DevOps world, there are metrics, logs, and traces. Do we still care about these things in data observability? Because yeah, it's still probably important, or it's less important than these five things. Do we still
It's
need
a
to think about them?
Yeah, it's a great question. I'd say, we definitely still need to think about them. It's just two different ways to think about a system, right? And you probably can't run a very healthy system with only one or without the other. And oftentimes we call it the good pipelines, bad data problem. So you might have like really reliable, great pipelines or great systems, right? And you're still sort of tracking the observability from an engineering perspective, but the data itself that's running in your pipeline is inaccurate, and that's why you need data observability. So don't get into the good pipeline, bad data problem.
Okay, so the idea here is we still need these three, so we still care about DevOps, right? So because
Yes.
if I may use this analogy, so we have this DevOps and we have DataOps, right? So we have observability and we have data observability, right?
Yeah.
And it doesn't mean that we stop caring about all the other things, right? And care about these five. We still need to be on top of good engineering practices. We still need to care about all these DevOps practices, right? And we add on top of that. So we take these three pillars to make sure that our systems they have the observability from the engineering point of view, and we add five on top, and then we have good pipeline and we have good data, right?
Yes, that's right. That was spot on.
Okay.
Yeah, we often find that data observability, data engineering teams are really busy. As they have a lot of things to do, and data observability actually, saves. We see a significant reduction in time when data observability is used in practice. Things like 120 hours per week on average, for like a 5-person team, and a reduction of almost 90% of data incidents when you think about sort of when teams practice data observability. So yeah, you're spot on. We can't use one. We can't only choose one. It has to be based on some of the best practices. There's significant impact.
Okay. And I noticed that you often say observability and monitoring. Is there any difference between these two things, or is it like, are they synonyms and we can use them interchangeably, or they're two different things?
Great question. So monitoring is basically a subset, if you will, of observability. So observability basically tells us, based on the output of a system, what is the health of that system. And so observability basically helps us answer questions about the health of a system based on the results that you get in monitoring. And so monitoring will tell us, this system is operating as expected and it's healthy. Monitoring will tell us, hey, there is an outlier or a problem with the system here. You have, there's an indication of a freshness problem, for example. A table has not been updated. But observability will help us answer the question of why this is happening. We'll see, okay, there is a problem, there's a freshness problem. What is the root cause of that? And then also, how can it be solved by means of answering what depends on that table, who relies on it, is it an important table to troubleshoot or not? And so you actually need both. And I see monitoring as a part of observability that helps us answer these questions.
Okay, so if I'm just trying to think of an example. So let's say there is a job that is producing data and it stopped working. So now we have monitoring in place that says, okay, we expect that in this table, the data appears 3 times per hour. Right. But it's been 1 hour since it appeared and nothing is still there. So we get an alert, right?
So something is wrong.
Yeah, so somebody, a data engineer, or maybe somebody from operations get a pager duty call saying, hey, something is wrong with the data. And so it doesn't tell us what went wrong. It just tells us that something is wrong, right? And then using other tools and other pillars like this lineage or some other things, we try to figure out what actually went wrong, right? Or how does it work? How do we go from simply monitoring sending us an alert, hey, something is wrong, to actually finding this root cause?
Yeah, that's a great question. So the other pillars can, in your example, the other pillars can give us clues and help us understand, why this happened and what we can do about it. So for example, if you mentioned, let's say we get, we have a strong monitoring system and we get an alert on a freshness problem. And then we look at that table and we actually get, we see that at the same time, 3 other tables downstream also had a problem. And we see that those are correlated. So they happen, sequentially, for example. That can help us give clues around sort of, what's the impact of this? And to your point, sort of using lineage, maybe we can see, okay, you know what, there's a bunch of other tables further downstream that rely on this, and they're going to be impacted later today. So, we need to sort of stop the data from going to those tables, or we need to, fix this immediately, right? So that gives us clues as to like, how can we actually solve this, for example. Another example for understanding why this is happening. So let's say, we see that there's a freshness problem. We want to look at, say the query logs. We want to understand like who's making updates to this table. So I can actually, ping the right person or the user of this table to better understand, why they're using this table. Is it important or not? When are they using it? So actually using metadata about this data, getting data driven about our data can help us answer that. So the way that I think about observability is basically, getting data driven about your data. And that includes, knowing when things are wrong, like monitoring, but answering a bunch of other questions too.
And which makes me think who should be responsible for. So I imagine like usually the setup, maybe it's different, but there is usually some sort of central data platform. And then there are teams who publish to this platform. There are teams who consume from this platform. And I'm wondering here whose responsibility is to actually to make sure that, that the data is there. I think so. The platform probably can help us with making sure that there is freshness, and yeah. But it's if the the producers of the data start publishing some data with errors, there should be some process that lets them know, hey, something is wrong, right? So should it be the team who implements these checks, or the platform tells them, hey, something is wrong? Or like how is it implemented usually?
Yeah, great question. So I will say that it very much depends on the maturity and the size of the data organization, right? When you're a very small company and you have maybe one data engineer, right? Like the lone data engineer, he or she are typically responsible for everything. So they're going to be, setting up the system and receiving the alerts and troubleshooting it and letting everyone know, right? And then we'll take the other.
Wi-Fi. Right.
Exactly. Plug and unplug, see what happens. And in a large, let's take like a large company where you might have 30,000 people consuming data, and you have a team of a data team that's several thousands of people. In those organizations, one of the sort of things that we're seeing is people moving towards a decentralized model of ownership, where basically you have sub teams of data in the data organization, and those people have ownership on basically on that data. And so in those cases, organization actually make data observability and data monitoring self-serve. And so there's typically a centralized group that's responsible for saying, this is the platform that we should be using for data observability. And for each data team, for each sub team, that sub team actually defines how they engage or interact with that platform. And so that sub team will receive personalized alerts for their data assets only. And so oftentimes, as companies move from being very small to being very large on that trajectory, we're seeing different models along that path. I think one of the main questions that people ask us is like, who's actually responsible for this, and how do we set accountability? One of the ways that we're seeing companies deal with this is with a framework called RACI, which basically helps to determine accountability in organizations. And so RACI stands for R is responsible, which is basically the person who is executing on the specific task at hand. A is for accountable. So it's a person whose neck is on the line. Like it's sort of their main job to make sure that this, like they're the people held accountable. C is consulted, meaning they need to be, their opinion might count, or you'd want to seek their opinion about something. And then I is for informed, meaning someone needs to know about something. And so for each part in the data lifecycle, you can define who is responsible, accountable, consulted, and informed. And you can use that to determine what's right for your organization. So for example, for specific data observability or data quality problems, we can say, okay, chief data officer or the CTO is the person who's accountable, has the A, but the person who's actually solving that is the data engineering team. The person that needs to be, or the organization that needs to be informed, meaning I, is the data analyst team, for example. They need to know about problems, even though they're not responsible for the jobs in the pipeline specifically. And so you can use this framework to help allocate, who needs to do what and when, and basically clarify that. So you're not in a position where there's one person doing all of that.
Yeah, I'm just thinking about what I'm doing. So I'm a data scientist, and I build models, machine learning models, usually using data that some other teams produce. So let's say there is a team that produces this data source, there is a team that produces that other data source. So what I do is I join these two data sources and build something on top of that. So in this case, I guess I would be informed. So if something goes wrong, somebody from these teams reach out and say, okay, sorry, there is some problem with the data, right? And they are responsible, right? So they're responsible, they're reaching out to me, and probably the accountable person, I don't know, maybe a product manager in that team, or a manager in that team who is accountable, So this person would be doing, communication, saying, "Hey, sorry, like I know you use this data, I know you rely on this data, but something happened, or I don't know, server died, or there was a bug and the data is not there. Sorry." And the data engineers, in the meantime, are trying to fix it, right? Is it
Yeah.
more or less like that? And
Yeah,
I
that's a
guess
great example.
it also makes me a bit puts me in the consultant category,
Yeah.
because I could be a stakeholder. I can say, okay, you know what, you promised this data with a delay of 1 hour, but this is not enough. Can you make it a bit, faster, quicker? I like smaller delay, right? So they if they care about my opinion, then it means I'm consulted, right?
Yeah,
Is
exactly.
it
That's
right?
right. Yeah, you got it spot on.
Okay, cool. And so what do we do with this? I guess so responsible and accountable, this is the team that actually puts the data. So if I'm a data scientist, I want to make a model based on some data. I go to this team and ask, so what are your, like I think the right term would be SLA, right? Service level agreements.
Yeah.
So can you promise me that the data will appear there 5 minutes after the user made an action, right? So this is, so we make some sort of agreement between our team and the team of data engineers, right?
Yeah.
And then you said that in bigger organizations, so in small organizations, it would be one data engineer who is doing everything. But once a company becomes bigger, we could have this centralized platform where teams could define their these SLAs and whatnot, saying that, okay, we promise that the data will not be delayed more than by 5 minutes, right? And then they say, okay, the freshman requirement is 5 minutes, right? And so this is there is agreement between us, and then they start pushing the data to the platform, right? And then when something goes wrong, the system alerts them, and yeah, and I guess now data engineers fix it.
Yeah.
Right?
Yeah, that's exactly right.
So do you want to add something there? No?
I think you did a great job of explaining that. I think that's
Okay.
perfect.
Okay. Yeah, I think you are the
Yeah.
podcast guest, right? No. Thank you so
Yeah,
much.
no, it's perfect. I much prefer it, when you do such a great job of explaining this. But yeah, no, that's spot on. I think in the same way that we've adopted observability as a concept, like also SLAs is something that's like super common, right, in engineering. But we haven't adopted it in data yet. But we can, and it'll be helpful for us to have that communication agreement, because the value of that, actually, like why it's important, is because it'll help your data engineering counterparts know what to focus and what to solve for, right? Imagine that they have like hundreds of tables that have freshness issues. But there's only 10 of them where they have an SLA, a particular SLA for freshness and timeliness, that's like this 5-minute window. Then they will know to prioritize those, and maybe the rest can wait for later, right? So it provides some sort of agreement between you two on what actually matters to you, and you can give the information of these tables matter more, this data set doesn't matter at all, etc. So it actually allows us to have better communication and to also not waste our time on things that don't matter.
So here, I guess there are a few crucial components. So first, we need to have this platform that allows us to define this defines these requirements. Like we have these expectations for freshness, we have these expectations for volume, or I don't know, maybe for volume we don't even need to define that. Maybe it should be like, okay, something is wrong because yesterday it was that much, but today is less.
Same for freshness, actually.
Yes. Ah,
You can
okay.
say,
Yeah.
you can actually, here's the cool thing, is that for a lot of these, actually for each of the pillars, there is a component that can be automated to begin with. And so what I believe is that we've underinvested in automation in data, which is kind of ironic, but I do think we have. And so teams are used to saying, okay, I need to define, that this, that the volume here needs to be this, or that the freshness needs to be to your point. But really, you have historical data about that. And so you can infer what is the volume that you expect. And you can also infer, okay, this table is being updated 3 times an hour, so it should be updated 3 times an hour. And obviously you can add customization on top of that. So you can say, no, actually, in your example, I want this data to arrive faster. Can you make sure that that happens? So I definitely think that we need to start with sort of a layer of automation and then add on top of that customization. But I would start with what we already know about the data.
Yeah, because I mentioned that we are not starting from scratch. There are already some processes that push data somewhere. There are processes that read data from somewhere. And it's not like we have a blank page, right? So there is already something, so we can just see, okay, like here, usually something arrives within 5 minutes. So yeah, let's just use this as a SLA, right? So we can infer this from the past. But in some cases, we should have a way to override this and say, okay, yeah, let's make sure it arrives earlier, right?
Yeah,
but in any way, we need to have this place there. It's possible to define this, and then we also need people who take responsibility. They say, okay, we are going to stick to these SLAs, and if something is wrong, we are going to make sure that we recover as fast as possible, right? So we need...
you can even have a monitor in your office that shows, here's the SLAs and here's how well we're doing and we're crushing it. Yeah,
in the office, so
yes.
nobody sees it.
Exactly.
Yeah, I'm wondering how this
in your virtual office.
Yeah. Okay, that's a sad topic.
Yeah.
But anyway, so we have these two things. So we have the platform itself, like the tool that lets us define all this. So then we have this framework, RACI, to identify who is responsible. So we have this people aspect. So do we need something else to make it work? This observability, to have observability in place?
That is a great question. So I would say that's a good start. If you have both of those things, you're off to a great start. There's probably different, maybe the only additional thing that folks do is they start defining playbooks and runbooks for what happens in these instances, basically workflows. So, let's say, there was this table that you expected to get updated 3 times out an hour and it stopped getting updated. And then there's a whole set of things that happens, right? The first is, to your point, you get informed because your model actually relies on that data. And then the data engineers need to take some actions in order to resolve that. So what are those actions? What exactly are they doing? What systems are they using to look at to solve it? Who do they need to know? How do they resolve it? All that stuff is basically like a run book is another thing that typically folks define. But you know what? I think even if you have, if you get started with what you mentioned, you're off to a great start.
Yeah, so let's talk a bit how we implement this. So what are and there is actually a question, but I also wanted to ask this question. So the question is, what are some of the good tools in the marketplace that provide good job at data observability? And I think I know what you are going to say.
Well, you've been doing a great job of that, so you can go ahead and answer.
You mean Monte Carlo, or?
I can provide an answer, for what folks are doing, if that's helpful. I talked a little bit about sort of this kind of like maturity curve for how people manage from like a small company where there's one person who's sort of doing everything, and then there's a large company where you have like you might have a decentralized model and you have different ownership. And so actually, as I mentioned, we talked to hundreds of data teams, and there's sort of a maturity curve for how you deal with data downtime as well. So in the very, very early stage, you might be in a very reactive phase where really you don't have anything in place. And you have basically disasters all the time. I remember the CEO who told me that this is back in the day when there were offices like, they would like walk around and put sticky notes on reports and saying like, this is wrong, this is wrong, this is wrong, right? So that's like a very, very reactive stage. The first stage or sort of the second stage, when people start thinking about how to solve this in a more proactive way, it's sort of called the proactive stage, is when people they put in place some pretty basic checks, right? It can be just row counts, right? I'm going to like manually sort of select a bunch of tables and make sure that they, get 1 million rows every day, because that's what I expect. And then those teams spend a lot of time in like retros and post-mortems and figuring out what's wrong. The third stage is sort of automated when they sort of start, when they recognize that a manual approach is no longer scalable or effective. And so they basically, start implementing some solutions, and we can talk about what those are. And then the fourth stage is like scalable, when basically, you have companies are really invested in both the scalable and automated solution. Some of the best in class out there, you can take a look at Netflix, has written a lot about what they've done for monitoring observability and detecting anomalies. So, I think it ranges from sort of things that you can hack together, do on your own, where you can basically, using SQL or Python or Jupyter notebooks, and actually we put together some tutorials on this. So I'm happy to share the links after if that's helpful for kind of creating your own monitors. The other thing that you could sort of do is kind of look at specific area in your pipeline, and sort of define kind of specific tests in those areas, like in Airflow or something like that. But really what we're finding is that as data organizations are getting, as we talked about, like actually using their data and getting more serious about data downtime, they do need a holistic approach. And so whether it's sort of an open source tool or something, sort of a bespoke solution that's easy to get up and running with, there needs to be something more holistic than sort of a point solution.
Okay, so like you mentioned that you can at the beginning get away with a bunch of counters. So like just count how many rows appeared in the each hour, let's say, and then you can at the same time check what is the date of the last when, let's say, when you insert row, you can add some sort of a timestamp to each row, right? And then you can just look at the max value of this column, which will give you the freshness, right? So I guess you can get away with a bunch of things just doing using plain SQL and a bunch of Python scripts, like you said, but that would put you to the proactive stage, right, in this maturity curve, or
yeah, that's right,
already
exactly.
automated.
I would say it's somewhere between in the proactive stage. Yeah, that's still pretty ad hoc.
Okay, so how do we go to the, like you said, we need some sort of holistic picture. So how do we get this holistic picture if all we have is a bunch of ad hoc stuff put together with a duct tape that does some sort of alerting already? Let's say maybe there is an email to some of the people, hopefully, or I don't know, a Slack message from a bot. That's already quite good. But like, how do we go even further? Like, how do we go to the automated phase?
Yeah, so in that case, you probably will need an observability solution. And yes, full disclosure, Monte Carlo does have an what we are doing is, we've built a strong observability platform. So that's definitely the core of what we do. Some of the characteristics that I think are important for a strong observability solution. One, it needs to give you end-to-end visibility. So it actually needs to connect to whatever your data stack is, including your data lake, your data warehouse, your ETL, and your BI or your machine learning models. So to take an example, if you're just doing row counts in only a handful of tables in your data warehouse, it's probably insufficient because you are relying on data arriving on time in other areas and a lot of the data moving in different systems. And so I would, if I were to choose an observability solution, it would be one that can actually connect to my existing stack, and end to end. So including the data lake, the data warehouse, the ETL, and the BI solution. It's also, I think it's important to choose a solution that automatically learns your environment and your data. So we talked a little bit earlier about whether you manually define the thresholds or you actually rely on automation. And I think solutions that sort of rely, to your point, we're not starting from scratch, right? And so solutions that can actually do the instrumentation for you and start the monitoring for you, using machine learning models based on historical data, I think that puts you at an advantage. I think another key point is minimizing false positives. So data teams, often have alert fatigue. And so if you actually have a system that can take into account not only the data, but also metadata and thinking holistically about the 5 pillars, right? Each one is important and has to include things like lineage, for example. Then that can help minimize false positives and give you rich context about each of the incidents so that you know whether you should take action on it. So there's certain criteria that you should look for when you're thinking about the data observability solution. And that's definitely the way to kind of improve the health overall and move up in the maturity curve.
Are there some open source tools for that?
There's open source for different specific solutions, like for each of the pillars, but not one that sort of does comprehensive for all of those 5 pillars.
I'm wondering, I think the most difficult thing, in my opinion, maybe I'm wrong, is this lineage. Like, how do you actually define all these dependencies? Is there a good tool for that?
There are different levels of lineage. So for example, Airflow provides job level lineage, for example. But for table level and field level lineage, something that automatically reconstructs that, I actually haven't seen a very strong one. If anyone, if there's anyone in the audience, I'm curious to hear if there's anything that I've seen out there, but not that I've seen.
Okay, yeah, so we have a couple of questions from the audience. Maybe we can go through them. So RK is asking if you know any good approaches on test-driven development in the data space, and does it have to do anything to do with data observability?
Sorry, can you say that again? I don't think I got
Yes,
the first part.
so there's this test-driven development. This
Yeah.
is like a way to develop things in engineering.
Yeah.
So are there some similar approaches in the data space to that, and how we go about testing in data?
Yeah, great question. And this is sort of I think the ultimate question here is like, maybe what's the difference between testing and monitoring and or testing and observability, and what does that mean for us, right? So going back to software engineering and to what the importance of testing in software engineering is critical, right? Like, you'd be crazy to release something to production without testing it thoroughly, right? Somehow in data we actually do that, right? So somehow we actually don't always have strong testing in place, and so definitely putting in place strong measures for testing too is important. I think you need both, right? So you can get away just with testing. Some of the sort of common pitfalls that we see are teams that think that just testing is sufficient. The problem with that is that you don't know sort of, it's like the unknown unknowns, right? So you can, in testing, you need to specify things that you know might happen, right? But there's always going to be things that you didn't pick up on. And so monitoring helps make sure that if and when something happens, you will know about that regardless. So I'm a strong advocate of both. And you can define tests, like, for example, if you have a solution like dbt, for example, you can actually define data quality tests in dbt to help make sure that you're doing testing properly. So 100%, I think that's super important, and another great area that we can adopt from software engineering.
And these data quality tests, we again define some sort of ranges, or that for this sort of input, this is the sort of output we expect, or how did this work?
Yeah, exactly. Like, defining basically sort of manually what you expect out of, making sure that, specific sort of null values are in a specific range, or, basically specific things that are often breaking or incorrect in this data that you want to test. Some of the sort of problems that occur, some of the common pitfalls that we see is that one, as I mentioned, like, there's some unknown unknowns, so you don't always know what to test for. And then the other thing is that it's actually quite time consuming. So, there are folks who might define like thousands of tests. And so for a data engineer to go through that, it's actually quite laborious. And so I would really think of a strong strategy would incorporate both testing and monitoring as well to kind of mitigate those.
Yeah, thank you. Do you know if the big vendors, big clouds already move into this space of data observability, or it's still not really, they're still not really focused on that?
Yeah, it's a great question. So, at Monte Carlo, we're actually we've partnered with Looker, which is acquired by Google. So with GCP, we've partnered with PagerDuty, and we've partnered with Snowflake. And so this is definitely something that I think the large vendors or the large kind of cloud providers have noticed as something is important. We hear a lot from them that this is something that comes up a lot for their customers. And so, something that they want to provide a strong solution for. So I think this is definitely something that is becoming more and more important. Yeah.
But typically, should this be agnostic of a cloud compute vendor? Like, let's say, because I imagine if a company is on AWS, it's quite a vendor lock, right? If you want to solve a problem for somebody who's on AWS, then you cannot be cloud agnostic, right? There are so many things that are cloud specific, like I know on AWS there are S3, Athena, all these services. So the question is, can it be cloud agnostic, or it's difficult?
Yeah, definitely. It's a great question. So for us, the observability, our observability platform, actually we integrate with all cloud data lakes and data warehouses and BI solutions. So integrate with everyone that you mentioned, GCP, AWS, and all others as well. And I think that's important because, as I mentioned, I think a good observability solution will actually connect to your existing stack, and you don't have to change, to a different provider for that. And so, yes, it has to be agnostic, actually, and in the same way that it is in engineering, right? So, for example, like Prometheus, Grafana, New Relic, Datadog, they connect to sort of whatever you have, right? Whatever systems you have. And so I think it has to be a requirement in the same way.
Okay, and then you can also use Kubernetes for your jobs, right? And then it's also cloud agnostic, right?
That's right.
Yeah. Another question from RK. What are your thoughts on centralizing the observability in a distributed environment where we have multiple different data warehouses and data pipelines and etc.?
Yeah. So thank you for the question, RK. I'd love to dig in deeper and better understand your environment and see how I can help. It probably requires sort of a deeper dive of your system and your infrastructure to better understand. But I will say that even in an environment where you have distributed ownership, it's important to define it's important to define a centralized way. What, to your point, like, are we doing SLAs as an organization? Is data reliability important to us? Do we care about having trust in the data, right? And that needs to be in some centralized fashion, potentially needs to be decided, but also each team can decide that, it's important to us to make sure that we're delivering reliable data. And then each team can actually define sort of the SLAs for their own organization. So I think observability matters regardless of what whether you're in distributed or not, or centralized, because providing trust in data is important for everyone, regardless of like what your structure is and what kind of data you're dealing with. If you don't have trust in your data, that's the worst thing that can happen to you. If you are producing data that people can't use and can't trust, it's really probably sort of the biggest threat to us, honestly, as an industry. And so regardless of that structure, there's different ways to adopt it and to implement it. But regardless of that, data observability should be core to your strategy.
Thank you. Do you have time for a couple of more questions?
Yeah, sure thing.
Okay, so we have a question. Wait, I lost it. So how Monte Carlo detects upstream and downstream usage of data?
Yeah, so Again, happy to go into more detail if folks want to reach out to me
Maybe there is
directly.
a link that you can share after the
Yeah.
talk.
Yeah, so feel free to email me. My email is Barr, BARR, at montecarlodata.com, or go to our website, montecarlodata.com. And I'm happy to also share the link after and get into more details and talk about this. But at a super high level, what Monte Carlo does is we actually have a data observability platform that is based around these 5 pillars. And so as part of our lineage pillar, we actually reconstruct both the upstream and downstream dependencies and basically reconstruct the lineage for a particular system, whether it's your data lake, your data warehouse, your BI. And we actually do that across your systems as well. So we do that automatically. There's no manual input. So happy to go into more detail, if you want to reach out directly to me.
And then I noticed that you also joined our Slack. So I think that's another way of contacting you, right?
Absolutely. That's a great point. Yes, I'm a big fan of the community that you're building, and I am available on Slack. So happy to take any questions. Feel free to send over.
Yeah, thanks. So maybe just the last one for today. So how do you differentiate between getting bad data and getting uncommon data, which might actually be interesting but not wrong?
Yeah, fabulous question. So if I will rephrase that a little bit, I think the question is, I might get notified about something, but it is intentional, meaning it's not bad. It's just different. It's just unexpected, but maybe it's a good thing. And you're right. I don't think we can actually necessarily discern that. And also, I'm not sure that actually matters. And I'll say why. I think people want to know about changes in their data, even if they are simply uncommon, right? So let's say you had a crazy spike, or you got, instead of the 1 million rows, you got 10,000 rows. Maybe that was intentional because someone made a schema change upstream. And maybe that is still good data. It's not bad, but you still want to know about that because that has implication on your machine learning model. And so I think a good observability solution will let you know about both instances, and will provide enough context about each event so that you can make the decision, or someone can make the decision whether this is uncommon or bad, to use that terminology. But we need to know about both. And the more context you have about that event, the easier it is to make that discernment and know what are the action items to take based on that.
Should we actually get alerts every time there is a suspicious row, or it depends? Like, let's say we have a volume of 1 million rows. Do we want to get an alert for every unusual one, or?
Yeah, probably not. You probably will get alert fatigued, right? You probably want a system that is a little bit more sophisticated than that. And so at Monte Carlo, we've invested a lot in making sure that, we send alerts for events that matter. So, if this is like a table that is highly used or highly queried or has many dependencies downstream for machine learning models that are really important, or there could be other instances or other ways to identify whether something is really, really important. But I would definitely say you want to be very thoughtful and making sure that you are being alerted and taking action on the things that truly matter to your system.
Okay. Yeah, so I think we should be wrapping up. Maybe do you have any last words before we do that?
I would just say thank you for the time. Really appreciate it. Yeah, and if this is a sort of a topic that's near and dear to my heart, so if anyone wants to sort of continue the conversation, I'll be on Slack.
Okay, thank you. And I'll put some contact details, Twitter and LinkedIn in the description. And yeah, thanks a lot for joining us today, for sharing your knowledge and experience with us. And thanks everyone on the stream for listening, for tuning in. And I wish everyone a great weekend.
Have a great weekend.
Yes, so nice talking to you.
Yeah, likewise.
Goodbye.
Bye.